that companies use to describe the massive amount of data they now capture, store, and analyze. Everyone is talking about big data, which means there's a lot of data. All right. So if we're talking about data, there's a 4 V's we need to understand. The data volume refers to the amount of data created and stored. We also have the data velocity, refers to the pace at which data is created and stored. Right? So the high speed, which means we have a lot of data coming in, right? And we also have the data variety, refers to the different forms of data. And also the data veracity refers to the quality or trustworthiness of data, which means that all the data can be verified, right? So the key for accountants, we're going to develop analytics mindset. So this is a mindset as a mental attitude, a way of thinking or frame of mind. An analytic mindset is a way of thinking that centers on the correct use of data and analysis for decision making. So the accounting firm Ernst & Young, they have a study, and they published what is their analytic mindset. Okay, according to their research, an analytics mindset is the ability to do the following things: to ask the right questions, to extract, transform, and load relevant data, to apply appropriate data analytic techniques, then finally interpret and share the results with shareholders. Okay, these are the things accountants are needed, are supposed to be familiar with. And also in the coming, CPA firms, I think there's a trend towards understanding big data, understanding the data analytics. So we're going to see more and more of those focus in the near future. Right, so first, about mindset, ask the right question. Okay, so what is a right question? A good question, okay, will be smart. So what is smart? Be specific, okay, be measurable, be achievable, be relevant, and then be timely. Okay, so you're going to check what are these meanings. So it's not difficult to understand. Alright, so test it. Then the second point to have an analytics mindset is to extract, transform, and load relevant data. Okay, so we should have the technique to do all these things. This process is also known as ETL, right? Extracting, transforming, and loading. ETL process. Now this could be a time-consuming part of analytics mindset process. Sometimes very time-consuming, and so also we call this dirty work. So a lot of work to do. We're going to talk about those things, and also with the technology, it can be achieved with automated systems. Okay, so we have a lot of now reading the financial statement is no longer need human beings. Okay, all those financial filings are now read by programs and become automated. So given the importance of ETL process, AICPA has developed a set of audit data standards, okay, that can help with the process. You can review these standards at this with this link to see what AICPA says about ETL. Alright, so we're going to go through ETL briefly. We start with extracting data. Again, several steps. Step 1. We need to understand data needs and data availables. To understand data. So we need to understand the data comes in several forms. Basically, we have structured data, which is a data that is highly organized, right? And it fits in fixed field. For example, financial data, right? The balance sheet, income statement, those are structured data. We also have unstructured data. That is, the data has no uniform structure, like PDF files, right? Pictures, videos, music. They are data, but they are not structured. And also have semi-structured data is something in between. There, some part of the structured has been structured, but not all of them. Right? So these data will come into the company, and then we're going to store and do the ETL. Data is stored in several structures again. We have a data warehouse. Data warehouse is a storage of structured data from many different sources in an organization. That's a data warehouse. We also have data mart. It's smaller data repositories that hold structured data. Okay, so you can think data mart as a department of the company. If the warehouse is a company, then data mart is department. We have a smaller part. Then we have the data lake, which is large, huge. Data lake is a collection of structured, semi-structured, and unstructured data, okay, in a single location. All right. So let's take a look at how these data are stored. So this circle one means structured data. Right, structured data will be stored in the data warehouse. Okay, and the structured data can also be stored in data mart. Okay, that's for a small, more specific section. And the structured data, and this means unstructured data, will together will be sent to data lake. Data lake. So the data lake could be like a folder, right? For example, the folder for a business school, right? We can put all the structured reports or videos or any pictures, everything into that folder that we call this data lake. This is the one way. Or the other way, the structured data will be stored first in the data mart. And then from data mart, we're going to summarize all these data to data warehouse, then send to data lake. Okay? Or the third way, both the data mart and the data warehouse will be updated simultaneously with the structured data. Right? Then the structured data will be sent to data lake together with unstructured data. Okay, so we have three ways to design to store data. What's the problem with all this big data? Okay, so with so many data, we may have dark data. Those are the data we collected and we stored, but we never use them. Right? There's some statistics saying that on average, right, 90% of data will never be used. You collect not, so a lot of data you collect will never be used. That's dark data. We also have data swamp. Okay, data swamp are those data that you stored, but you do not accurately document where they are or what they are. Then you will lose a clue later on that we call the data swamp. Okay, so to handle these problems, especially data swamp problems, to identify the data we want, better to have the build a data dictionary, and we call this called a metadata, which is a data that describes other data. Okay, like a dictionary, so we can find where the data we want. That's a step 1, understanding data. Step 2, we're going to perform the extraction. Okay, so with permission, data is extracted into separate files or into a flat files. We know the data will be extracted from the relational database, right? So we may have multiple tables, or we can have a combined table, and we call this flat file. So flat file might combine the information from multiple different tables into a single table of information. So we may reduce information in a relational database through aggregation. We may lose some information, and this flat file, this big table, will violate the design principle of a relational database. But that's fine. We're going to analyze it. Okay. So, what does a flat file look like? So a flat file will contain a text, right? Words, numbers, everything together. But how can we tell? How can we separate these information into different fields, right? For example, how do I know which one is for database, which one is for name? Right? And here we need the delimiter. Okay, the delimiter, for example, a comma or sometimes pipe. The delimiter is going to tell us or tell the program the end of the field and the beginning of the next field. So it separates field easily. Okay, that's a delimiter. Also, we have the text qualifier. A text qualifier is, again, that's 2 characters that indicate the beginning and the ending of a field. And it's going to tell us or tell computer program to ignore any delimiters inside. Alright, so let's see some examples. What is delimiter? What is text qualifier? Okay, for example, the information we read is this one, original information, right? We have friend, a first name, last name, right? Performance score, and then we have the performance review. As you can see, the pipe, this pipe character, right, separate these fields. And also this quotation, right, is going to is the text qualifier. Okay, so anything within this quotation will be performance review. Now, so let's read the data rows. Let's read the data rows. We have Renee Armstrong. Okay, pipe. 99. Pipe. Smile a lot. Enthusiasm and could improve technique. So because Renee and Armstrong are separate by space, automatically it's going to be read into 2 fields, first name, last name, and 99 will be the 3rd field, performance, score, and because of these text qualifier, everything included will be the 4th field. Alright, so without a text qualifier, what's going to happen? In this case, we use the comma as a delimiter. So if you read the data row, Renee Armstrong will be read correctly and 99 will be read correctly. Without text qualifier, the smile a lot, comma, smile a lot will be read as the performance score because this is a force field. And the other two terms will be stored in an error, will be stored in error fields because they are not defined. They're not defined. So if we put back the quotation from smile a lot, enthusiasm could improve techniques, and the comma characters inside will be ignored, and the whole sentence will be read as the force field. Okay, this is what happens here. Okay, then we correct the problem. So this gives us some idea what is a delimiter and what is a text qualifier. Step 3 is verify the extraction. Several ways to verify extractions. We can have the batch processing controls, or compare smaller data extract with the full data extract and create a new data dictionary. So these are the methods we use to verify extractions. And typically, you can just pull out a small sample of your data to see if they are read or extracted correctly, right? Transforming data. So once we have extracted data, we're going to transform it. And let's see. There are 4 steps in the data transformation process. Understand the data and the desired outcome, standardized structure, and clean the data. Validate the data. Quality and verify data meets data requirements, and then document the transformation process. Transforming data. So we're going to move to chapter 6. Chapter 6, we start with transforming data. Attributes of high quality data. So what is a high quality data? High quality data must be accurate, complete, consistent, timely, and valid. Okay, so going to check their definition examples. So I'm not gonna go through it. So chapter 6, we have a lot of data process. We start with data structuring. Data structuring is a process of changing the organization and relationships among data fields to prepare the data for analysis. Extracted data often needs to be structured in a manner that will enable analysis. Specifically, we have aggregation, right? We need to aggregate data at different levels or join different data together, or pivoting the data, which means the row now become columns and column become rows, pivoting the data. Data standardization. Data standardization is the process of standardizing the structure and meaning of each data element so it can be analyzed and used in decision making. Right? One example is we're going to read the birthday data, okay? And a lot of times they're not standardized. Can have a different format of birthday, right? We have so many ways to write a date, so it needs to be standardized. Data parsing involves separating data from a single field into multiple fields. For example, right, we can separate to the date that's 2021 April the 1st, right, into 3 fields: year, month, and date, right? That's data parsing. We also have the data concatenation. is a process that combines data from two or more fields into a single field. For example, we can combine a person's last name and first name to get a full name, right? That's a data concatenation. And we also have cryptic data. Cryptic data values are data items that have no meaning without understanding the coding scheme. For example, a dealer's the data will show 1, right, 2, 3, and if by reading 1, 2, 3 we don't know what they are talking about, but the coding scheme is very clear. 1 is for Toyota, 2 is for Ford, and 3 for GM. So now we understand. So the 1, 2, 3, this is cryptic data. And sometimes we have a field contains only 2 different responses, typically 0 or 1, yes or no, true or false, right? This field is called a dummy variables or digitimous variables. They are not considered cryptic data because it's not that difficult to figure it out, right? People will figure it out, so it's not cryptic data. Misfilled data values are data values that are not correctly formatted, but that are correctly formatted but not listed in the correct field, so or was recorded into the wrong field. We call this misfilled data. And data formatting relates to ensuring that the same type of data is presented in the same way. Right? This is also data consistency. It is a principle that every value in a field should be stored in the same way. So these are the principles for data standardization. Data cleaning. Data cleaning is a process of updating data to be consistent, accurate, and complete. Dirty data, the raw data, a lot of times they are inconsistent, inaccurate, or incomplete. Okay? To be useful, dirty data must be cleaned. For example, there may be a lot of null values or missing values. So how to handle those, right? We need to clean those null value or missing value. We can delete them, right? Or we can replace it with some other values. We're going to talk about that. We also have data deduplication, right? It's a process analyzed to see whether there's duplicated or identical information, and then we're going to remove it. And the data filtering is a process of removing records or fields of information from the data source. Right? Sometimes it's irrelevant information will be filtered, or that sometimes it's harmful or confidential information that must be filtered before they are released. Right? Talking about the missing values, we call these data imputations. It's a process of replacing a null or missing value with substituted value. For example, we can replace all the missing or null value with a value of 0, typically. So it works with numerical data. Or we can replace it with a large number that is unrealistic, like age. If person's age is missing, you can replace it with 999. Okay? Instead of delete the observation, delete row, we can replace it with 999. So when you look at this age, you know it's missing number, but it does not hurt, right? Because we are not going to use that age for analysis. Data contradiction errors are errors that exist when the same entity is described in two conflicting ways. So in one row it says age is 50, the other row says age is 20. Okay, it needs to be investigated and resolved appropriately. Either we have to delete one if the other is correct, or delete both if both are incorrect, right? And we also have the data threshold violations. Data threshold violations are data errors that occur when a data value falls outside an allowable level, right? Again, use age as examples. If you read age is 200, right? Obviously, this is a threshold violations. It's over there. It's over the outside the normal lifespan. It's almost impossible for human beings, right? Violated attribute dependencies are errors that occur when a secondary attribute in a row of data does not match the primary attributes. Right? For example, right, you're going to describe a person's looking in one attributes, and the other attributes, right? It says it's he or she is from US, right? Then in the other attributes, you're gonna read information about the nationality. It says right, Japan. So obviously there's something wrong with the data. That's violated attribute dependencies. And finally, we have data errors. Those are all types of errors that come from inputting data incorrectly. Now, once we have the data problems, we're going to have the data validations. Data validation is a process of analyzing data to make certain that data has the properties of high quality data. It could be a formal or informal process, and it's important to have the data cleaned, and the techniques used to validate data can be thought of as a continuum from simple to complex. So sometimes we can make it really, really difficult or complex process. So what are the typical web methods we use to validate data? Okay, we can just do a visual inspection. Right, just take a look. Visual inspection is a process of examining the data using human visions to see if there are problems. Right? If you don't have a lot of data, just 1 or 200 lines, then it's not that difficult to see it. Right? You can check the data easily. But if you have more or a lot, then visual inspection is impossible. We can have some basic statistics to test whether the data is valid. So we're going to talk about that. Usually we're going to do the descriptive statistics, like take some mean, calculate average, right? Sometimes it's going to tell us a problem. For example, you calculate the average age of the people in the database, and you get to the average age 1,000. Obviously, some records, some data is wrong, right? Probably you recorded one of the age as 10,000. That's why the average now become 1,000, right? That's possible. So this is from the basic statistic tests. And also we can have audit sample. Audit sample, okay, could be one of the best techniques for assuring data quality. Just take a small part of the data, right? You're going to randomly select, for example, 1,000 rows from the data and thoroughly check to see if there's any problem. We can also have advanced testing techniques, right, that become possible with a deeper understanding of the content of data. All right. So multiple choices. Okay, once the data is cleaned and validated, we're going to load data. Okay, the transformed data must be stored in a format and a structure acceptable to the receiving software. Then programs may treat some data format differently than expected. A lot of times we have a problem with dates, right? This is different software may have different requirement. It is important to understand how the new program will interpret data formats. And once data is successfully loaded into the new program, it is important to update or create a new data dictionary. Okay, so you're going to tell people what they are about, right? All right. So now we move to chapter 7. Chapter 7, we focus on their data analytics part. We're going to analyze the data. After preparing the data, we're going to use it. We're going to apply appropriate data analytic techniques. We have 4, basically. We have the descriptive analytics. Basically, descriptive analytics is going to answer the question, what happened? Describe what happened. Then we have the diagnostic analytics. It's going to tell us, what did this happen? What did this happen? Give us a reason. Then we have the predictive analytics. It's going to tell us what is likely to happen in the future. And finally, the prescriptive analytics is going to tell us what should be done in order to achieve certain result. So let's talk about these 4 data analytics. So we start with descriptive analytics. Now basically, this is they are information that result from the examination of data to understand the past, to show what happened. We're going to show the basic feature of data, often use the exploration data analysis. What are the features of the data? We're going to show the attributes of data, such as the central tendency, right? What is the center? What is the center of the data, right? So we have mean, median, or mode to measure the central tendency. Not all data are located in the center. Some are spread out. So we're going to also see the spread of data. So we have the range, for example, standard deviation is going to show the spread of data. Okay, and also we need to know the distribution of data, right? Right, for example, are they symmetric, right? Are they skewed? Are they flat? Are there a lot of peak? Those are distribution of data. So typically normal distribution is studied in a lot of researches, and we prefer normal distribution because a lot of statistics techniques, they rely on the assumption that data are having a normal distribution. Okay, if they're not, then we're going to apply different assumptions. Sometimes it becomes more difficult to use those statistics if they're not normally distributed. Okay, And also we're going to check the attributes of correlations. Okay, correlations, which shows how two measures are correlated. Right, they can be, if they are moving together, they're positively correlated. If they're moving in opposite directions, then they are negatively correlated. If they are not correlated, right, we don't have a clue how they, what's their relations. So these are the attributes we're going to see in the descriptive analytics. Okay, and the visualization is a good way for us to see these descriptive analytics. For example, like, right, we know this is a normal distribution. It's symmetric, right? It has a very nice peak, a bell-shaped peak, and in a normal distribution, the mean, median, and mode will be the same line right here, right? If it's a skewed distribution, then the normal, mean, and mode will located in different places. Okay? And also we can see the spread out is very natural, right? We're going to check the standard deviation, right? The one standard deviation is contains about 67% of the observation. It's about right here. There's one standard deviation, and then two standard deviations should contain about 95% of all the observation data. And 3 deviation is going to give us 99%. Okay, so there's a lot of things. I'm sure these should be covered in the statistic class. Okay, for more readings, or you want to review what are descriptive analytics, you can read. Okay, this web page. It has a very nice, not very long, a very brief introduction of descriptive analytics. And the descriptive analytics is going to help us do a lot of things. We can understand the data, right? And also it's going to help us identify outliers. For example, when I talk about the age data, right? The age of 999 obviously is an outlier. If you draw the distribution, right? The 999 will located right over there, out of the range. And typically, it's going to tell you there are outliers, and you have to be cautious. Okay, you can either delete them when you do the analysis, or you're gonna apply other techniques to handle outliers. The second is diagnostic analytics, right? Basically, it's built on the descriptive analytics, and try to go a step further to answer the question, why did this happen? Give us a reason. Right? It could be informal analysis or formal analysis. Informal analysis often use logic and basic tests to explain why something happened. For example, if a company observed that the overall gross margin fell this year, they want to find out why. So typically they can just examine the mix of their product sold, right? They have a mix of high gross margin product, low gross margin product, to see whether this mix has been changed this year, right? And then once we find out why there are more low margin products have been sold, they need to go ask the next question, why we sold more low margin products, not high margin product. So this is an informal analysis, but they can give us an answer if we apply them correctly. The formal way to do the diagnostic analysis is through the confirmatory data analysis, in which we're going to do the hypothesis testing. hypothesis testing and provide statistical evidence. Okay, most of the scientific research is going to use this confirmatory data analysis. So let's talk about hypothesis testing. So first, we need to have a hypothesis. Right? A hypothesis is a testable statement. For example, if temperature increases, ice cream sales increases. Okay? It's testable. It's testable. Okay? So for any testable hypothesis, we're going to have actually two statements. There's a null hypothesis, which basically means there's no relationship between the temperature and ice cream sales. And then we have alternative hypothesis, which means the temperature and ice cream sales are related. Okay, so we're going to tell if we reject the null hypothesis, okay, then we find that the alternative one will be valid. So to understand the whole process, there are two errors will incur in this process. Two errors. Okay. So typically, what we try to do is we're going to find the relationship which the null hypothesis is false. Okay, and we prove that it is false, which means temperature and ice cream sales are related. Then we have the correct conclusion, evidence. Okay, but if we find that if our statistics find that ice cream sales and the temperature are related, okay, the data finds the null hypothesis is false. But in fact, the truth is the null hypothesis should be correct. They are indeed irrelevant and not related. Then we made a mistake. We call this type 1 error. Okay? So type 1 error is where we incorrectly rejected the null. That's type 1 error. And we also have the type 2 error. The null is false, but we failed to reject the null. Then we make type 2 errors. Okay, so they are important in hypothesis testing. Next step is we're going to select a level of significance for refuting the null hypothesis. Okay, or you can think this about the maximum type 1 error we can make. Typically, acceptable type 1 error will be 5%. 5% type 1 error will be acceptable. Any larger percentage of type 1 error are not acceptable. Alright, then we're going to start the test. We're going to collect the sample data and compute a probability value. For example, we build a regression model, we test the ice cream and the temperature, and we find ice cream sales equals in this regression is 10 plus 5 multiple temperature minus 2 multiplied by stock market performance in this model. Okay? Then the data return a probability level of 4% for the coefficient of temperature, meaning there's a 4% of the chance that this coefficient 5 should be 0, right? Because the null saying there's no relationship and this should be 0, and now we find 5. We are rejecting the null, but there's 5%. There's a 4% chance we are making mistakes, but 4% is acceptable. Therefore, this coefficient, okay, this relation, we accepted it. the null hypothesis, there's no relationship, has been rejected. About the stock market performance, the coefficient is 2. But this coefficient has a probability of 23%, meaning there are 23% of a chance we are making a type 1 error. That's a lot. That's above our thresholds of 5%. So here we say we fail to reject the null hypothesis that the stock market performance and the sales ice cream are not related. We fail to reject that null hypothesis. All right. So this is how we use a type 1 error and the test, do the hypothesis testing. All right. So be cautious, because we are still having a 4% chance committing a type 1 error. Okay? So this relationship, we are not 100% sure whether it's true. There's 4% of chance we are making a mistake. So we can never prove the null or alternative hypothesis are true. But in this case, right, we are supporting the alternative hypothesis with a 4% of chance making a mistake. But that's acceptable. The third one is predictive analytics, right? A predict analytics or information that result from the analysis that focus on predicting the future. For example, right, we can use a previous model to predict the next month's ice cream sales if we know the next month's temperature, right? We can do that. So a lot of times we are using machine learning, okay, to predict the future. So machine learning is an application of artificial intelligence that allows computer systems to improve and update prediction models on their own. So the predict models are not easy. It may have hundreds or even thousands of variables. And periodically we need to change the model, modify the model, right? There's a lot of work, right? And the machine learning is a perfect way to handle those work, because it can basically update by itself. Right? You can watch these videos to see to learn more about predictive analytics. And then finally we have the prescriptive analytics. Right? Prescriptive analytics are information that result from analysis to provide a recommendation of what should happen. Right? One example is UPS designed real-time prescriptive analytic solutions to optimize drivers' delivery routes. Okay, so they're gonna tell the driver which one is your next delivery, to save time and gas. So learn about the UPS prescriptive analytics in this video. So all four analytics are important, but they have a different value added to an organization, or of course different complexity. The descriptive analytics could be the easiest one to do, but also is the lowest value added, and the prescriptive analytic, the most complex one, but also the most value added one. Okay? Common problems with data analytics. We have data overfitting problems. Data overfitting problems occurs when a model is designed to fit training data. So when you use a training data, the model is perfect. But when we use additional data we put into the model, it does not work. That's overfitting problems because the training data is limited, okay? And the new data are very different from the training data. We also have the extrapolation problems. That is, right, when we use the model, again, we use a limited amount of data within a limited range, okay? And later on, when we put those data that are beyond the range of the data that is used before, the model will not work. And finally, we also have the variation problems. Now this can be explained by the weather forecast. The weather forecast is going to tell us tomorrow's temperature. How is temperature 80? But the result, the actual temperature will not be exactly 80. There's a certain range or variations. It could be 69.1 to 80.3. So there's a variation. Okay? So that should be considered. That should be considered for any of those models. A good model is going to give us, right, with a small variation, prediction or relationship. A bad models, those variations could be large, and sometimes they are not usable. Alright, these are the data analytics skills suggested for accountants, for future accountants. Okay, so I'm going to take a look at it to see how well you are aware, how many things you are aware of, or you have learned before, or maybe you're gonna learn these things in the future. But just take a look. There's a lot of things over there. Okay, interpreting the results, right? Once we do the analytics work, we're going to interpret. So there's several things we have to be careful. That is, correlations and causations are different things. Correlations tells the two things happen at the same time. Causations is going to tell us which caused which. Okay, they are two different things. And the second problem is the psychology issue. Psychologically, human beings are going to have some systematic biases. For example, if you like the person and when you give him or her evaluations, the score will be biased upwardly. That's typically what's going to happen. Okay, final topics, sharing results. How do we share people what we find? Could be the most important part actually, right? So we have multiple ways to present, but we're going to talk about visualization. Data visualization. Data visualization is the use of graphical representation of data to convey meaning. Okay, data can be presented in many different forms, but eventually we're going to present them in a visual way. That's the best way to do that. Okay, we have some specific way or format to present to present certain to serve different purposes. For example, the bar chart or the bullet chart are good for comparisons, right? And the scatter plot and the heat map are good for correlations. The box plot and histogram are good for distributions, line chart or area chart are good for trend, and then the pie chart and tree map are good for the part to whole comparison. So how do we design high quality visualizations? High quality visualization is going to follow these important principles: simplification, which means they are easy to interpret and understand. Okay, and emphasis, make sure that the most important message is conveyed or identifiable. Then ethical presentation. We have to avoid the intentional or unintentional use of deceptive practices. That's unethical. So here we have Tableau provides daily good visualizations. They collect a lot of visualizations they think are good, so you're going to take a look at it. Also, we have videos from YouTube. I didn't record this, it's from somebody else. It's going to tell us how to build Excel dashboard with pivot tables and charts, which are very useful to build high quality visualizations in Excel. So just give you some examples of what is good visualizations. For example, this is we try to simplify these visualizations. The top one is not simplified, and then bottom one is simplified. You can see what has been changed, right? We move these on the top of those bars to make the information to be more close. So we read appliances. These are for appliances, and these are for electronics, and this is for home electronics. So they are much closer. And also we have some other changes. So you're going to take a look, but the bottom one for sure are much easier to understand. Okay, and this one we use color to improve highlighting. Color should be used in a way that is going to make presentation easier, not colorful. It's not a piece of art. Okay, we try to present what we want to say. If you look at this the first graph, it's very easy for us to see, right? The home electronics, the annual income for home electronics department, ranked by their education. Very eye-catching. The middle one, we don't know what it's going to say, okay? And then the left one, or the right one, it's colorful. We know it wants to show the different color by different departments. But if we want to just check or focus on one of the department, it is not the best visualization to use. The first one could be the best. And this gives us example of techniques to increase visual weights. How to be eye-catching, right? We can use color. Obviously, this is eye-catching. We can use contrast, eye-catching. Complexity is going to also be eye-catching, or density, eye-catching, or just by getting bigger will be eye-catching. Well, this is an example of unethical visualization. Basically, we just compare the evaluation of the two person. One is 4.0, the other is 3.9, right? In fact, there's not much differences, but if you present in this way, it's not incorrect, but not ethical. Gives us a deception that Jason's much better than Anita. But in fact, they're not that different, right? So this is a better way to do the presentation. We have to start with 0 and show the data proportionately. And this is unethical, although it's 4.0, 3.9 proportionately, but the size is different. Looks like JSON is much better, right? The size is different. All right, this is your incomplete visualization is also deceptive. All right, some multiple choices. And finally, automation. Automation is application of machine to automatically perform a task once performed by humans. One of the things we want to mention here is robotic process automation. It's using the computer software that can be programmed to automatically perform tasks across applications just like human workers do. For example, companies are using RPA, robotic process automation, and other automation software to automate tasks within their analytics processes. Now, reading financial statements are now done by computers. RPA is one of the tools that can be used to automate ETL also. So watch these videos that explains RPA in a very simple way, just in 5 minutes. You can understand RPA better. All right, additional consideration. Data analytics is not always the correct tool to reach the best outcome, and it just helps us make better decisions. But we need to remember the importance of intuitions, expertise, ethics, and many other things. Right? Maybe for stock market investment, probably the most important thing will be the intuition and the expertise, because virtually everyone has the same data, same reports, and you better have a good intuition to make the best investment. All right, this is everything we have for this lecture.